This lesson is on inequalities and sets. This is the second half of chapter 7. So we kind of have already kind of mentioned some sets when I was solving equations, and we'll continue here building off of that. So again, a set is a group or a collection of objects. So numbers that belong to that set are also often called elements. So numbers that belong to that set are often called elements. So set notations when we use these, what we call braces. So when I see these braces, they stand for the words the set of. So that's the kind of the word phrase I use when I see that. So if we read this, we would say this is the set of 2, 4, 6, 8, and 10. Those would be the elements in that set. So when I use this notation, it basically can be translated into words. So it would be the set of even numbers between 2 and 10 inclusive. That's how I kind of would say that. The set of even numbers between 2 and 10 and that are inclusive. So inclusive kind of means you include those as well. As we move further into, some common symbols for sets. For cap letters, a lot of times we use these to note different sets of numbers. So N describes a set of numbers that we call natural numbers. A lot of times we call these counting numbers. So a lot of times you'll see this is the set of 1, 2, 3, 4, 5, and 3 little dots kind of means this set just continues on in that fashion. So we call that the set of counting numbers, the set of natural numbers. W stands for the set of whole numbers. The set of whole numbers actually starts with 0. It continues on that same pattern. 1, 2, 3, 4, 5, and then 3 little dots to kind of mean it continues on and on and on. Z is reserved for integers. Integers is when we get into positive and negative whole numbers. So usually there's like the 0 out here in the middle. Then if I go left, we'd have like -1, -2, -3, ... Then if you go right of 0, you'd have like 1, 2, 3, comma, ... Kind of represents that kind of pattern. Q represents the set of rational numbers. So the set of rational numbers basically is the numbers that can be expressed as a fraction. So, in this case, I actually have to use like this, I have to actually use words. The set of numbers that can be expressed as fractions. So that would be what we call rational numbers. Another one that's commonly used would be the letter R. Capital R represents the set of all real numbers. So real numbers is, we'll be using that quite a bit, maybe in this section as well. We'll talk about that more. Also in this section, when we talk about sets, there's also what's called set builder notation. The set builder notation is a very special notation that we use to describe sets. So the elements of the set are written in the form of an inequality to represent all the numbers in the set. So when you use set builder notation, an inequality will also be used in describing the numbers in the set. So the set of even numbers between 2 and 10 inclusive can be written using set builder notation. So notice how we have the set of x's. Notice how this vertical bar stands for, it's read as such that. So we have the set of x's such that x, and then we have this little e, or sometimes it's called the epsilon symbol. It stands for the words is an element of. So again, we have the set of x's such that x is an element of w. So what that means, we're talking about whole numbers. And these whole numbers are between 2 and 10 inclusive. But what also we're talking about is they're even as well. So there's a lot of numbers between 2 and 10, but we're talking about just even numbers. So that's how we can use set builder notation to describe the set of numbers, the set of even numbers between 2 and 10 inclusive. So we'll talk more about set builder notation as we move forward. So in using a number line to represent an inequality, the inequality will describe a boundary and a direction. These inequalities can be written in interval notation In other words, we're going to use like what we call parentheses or brackets. So this interval notation is going to be a special notation that you may not be as familiar with. So we'll introduce this to you at this time. So if we have the inequality x is less than 3, what this means is x is a number that is less than 3. So, and when we do that, we're talking about the set of real numbers. We use the set of real numbers because when you graph it, it's not going to leave any gaps. So if I want to graph this on a number line, what I usually put 0 out here as a starter, and then 3 would be to the right of 3 or to the right of 0. So 1 tick mark, 2 tick marks, 3 tick marks. So I have that. I can put a few more tick marks out there if I want. But the most critical one is where the 3 is. So notice that, if we have less than 3, notice how that's a right side boundary. So what I do is I have a parenthesis kind of going this way. And then that parenthesis there is considered an open boundary because we're not including the 3. And then notice how we're shading off to the right. So everything to the right of that is also being shaded. So it kind of takes on this look here. So what I can do then is use what we call interval notation. So using interval notation, what I can do is write this as, notice how the left boundary goes to the left forever. So when the boundary moves forever to the left, this is where we would use negative infinity. With negative infinity, we always use a parenthesis on that end. So if I'm using interval notation, we're going to have this negative infinity over here, and then we're going to have this comma, and then we're going to put our right boundary in, which is the 3, and this 3 is going to be an open-ended. We're not going to include it, so we're going to use a 3. So when you use interval notation, what goes on the left side is the left boundary. What goes on the right side is the right boundary. But since there wasn't really a left boundary, we use negative infinity. And there was a right boundary, which we use a 3, but we use parentheses, which means we do not include the endpoint. So if I have this inequality, x is greater than -4, again, if I was wanting to make a number line, I'm going to put 0 on my number line. -4 would be to the left, -1, -2, -3, -4. So I'm going to put that there. So then I have some more tick marks here to put down. So greater than, notice how it's pointing to the right. So the numbers greater than -4 actually are to the right. But notice how this says is greater than or equal to. If it's greater than or equal to, what that means is we're going to use a bracket to mean include. And then notice how we're going to be going to the right. So this is going to be shading to the right. So greater than or equal to -4. Notice how the -4 becomes a left boundary. There's actually not a right boundary in this. So we're going to use a bracket for interval notation. The -4 is the left boundary, and it goes towards the right forever. And since it goes for the right forever, we use infinity for that. And when you use infinities, you always use a parenthesis with that. And this is described as interval notation. So since the -4 is included, we call this a closed interval. So a bracket is always used when the interval is closed. A parenthesis is going to be used when the interval is open. And what that means is when the endpoint is not included. So if I want to graph this inequality on a number line, again, notice I have 1 and 7. So I'm going to kind of put my 0 off here to the left a little bit more. And then 1 is going to be located here. 7 is going to be located here. So it's going to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So notice how x is in between these two values. This is what we call a compound inequality. X has got to be greater than 1, and it's got to be less than or equal to 7. So notice how it has to be between those two values. So on a number line, notice how it's greater than 1. Notice how the 1 is my left boundary, so I use a parenthesis opening towards the right. And notice how the 7 is the right boundary, but notice how it's a closed interval on the right side, so we use a bracket there. So my graph is actually going to be between 1 and 7. 1 is open, but 7 is closed. So using that, I can kind of come down here and make my interval notation. But I need a parenthesis, not a bracket for the 1. Let's try that again. So the 1 is actually open, so we use a parenthesis because we don't include the 1. And then we have our comma. the 7 is our right-sided boundary, and we use a bracket since the 7 is included. So if we have x is less than -2 or x is greater than or equal to 0, so this actually is two intervals. So I'm going to put my 0 here. Got -2 is going to be to the left of it. Everything else just make my little tick marks. Really don't have to identify them. Just really identify the important critical points. So let's say you have to be left of 2. So on this one, left of 2 means the -2 becomes the right boundary, and you're going to the left. Or you also have this boundary. X has got to be greater than or equal to 0. So greater than or equal to 0 means you're using a bracket, and you have to be pointing to the right. So that would be that. So that's what this is going to kind of look like. So these actually have two intervals. Interval notation, we have to write both of these intervals down in interval notation. So the left interval, notice how it goes to the left. I have -infinity, which we have to use a parenthesis. And -2 is an open interval, so we also have a parenthesis. We use what's called the union symbol. That means to include. So instead of using the word or, we may use the union symbol, which means to also include the other interval, which again, the bracket is my left boundary, which is the 0, and it goes out to the right for infinity. So we have that going on there. So that's how we'd use interval notation using what's called the union symbol. So solving inequalities is where we're going to go next. They're going to be very similar to solving equations. There's only one exception. If each side of the equation is multiplied by a negative number, this impacts the this actually impacts the inequality. Because you remember when you multiply by negative, there's this concept of opposite behavior when you multiply. So to keep the statement true, the inequality symbol must be flipped to keep the inequality true. So when I solve this inequality, I'm going to solve it just like in an equation. But in the end, if I multiply or divide both sides by a negative, I have to flip the inequality sign to keep the truth. So that's the only exception. So let's see. Let's solve these inequalities. Let's show the solution set on a number line. And we also want to write this using interval notation. So if I want to solve for x, we just solve it like an equation. We have to get the x by itself. So to get rid of the constant, we put a -8 here. We put a -8 over here. So x is going to be less than -1. And since we didn't divide or multiply both sides by negative, that means the inequality symbol stays the same. So when I graph this, my 0 is going to be here. My -1 is going to be here. Notice how I have to shade to the left. So the -1 becomes my right boundary, and it's going to be a parenthesis because we don't include it. And we're going to be shading off to the left. So that'll be a rough sketch of the graph. So a lot of times I don't put all the tick marks in. Unless you just want to, you can. But really just the critical ones there is all you really need if you're just making a sketch of it. So if I'm using interval notation, notice how it's going to be the left boundary is the -infinity. The right boundary is the -1. And since it's an open interval, which means we don't include the -1, we use a parenthesis there. So that would be the interval notation for that. So what this means is your boundary is between -1 and, I'm sorry, -infinity and -1. And again, you always put the left boundary first and the right boundary second. So the left boundary is always to the left, the right boundary is always to the right. So if I'm solving this inequality for x, let's see here. So as we solve this inequality for x, notice how again, we just solve it just like in an equation. So we're going to lose 9 on this side as long as we lose 9 on this side to keep it balanced. So that makes our 0 pair, the 9 and the -9. So the x comes down, it's less than or equal to, and then a 12 and a -9 would make a 3. So x is going to be less than or equal to 3. So graphing this on a number line, again, I'm going to put my 0 as a critical point. 3 is going to be to the right of that. So it's going to be here. Notice how less than 3, notice how it's pointing to the left. So I'm shading to the left of 3. So notice that since it's less than or equal to 3, I use a bracket for that. And then I'm shading to the left of the 3 here. So that's what I should have. And if I want to put a few more tick marks in, I can. So that would be my shading of this is to the left of 3. So notice that, again, my left bound is negative infinity. If I'm using interval notation, my right boundary is 3, but notice how it's including the 3. I have to use a bracket for a closed interval. So if I want to solve this inequality for t, again, we have to get the variable on the same side of the equation to start with. So I'm going to notice how 1 is actually the smaller coefficient. So I'm going to subtract a negative 1t here, or subtract a 1t, and again, subtract a 1t there. This is now going to give me t plus 6 is less than or equal to 13. And then to get the constant out of the way, we lose 6 here, we lose 6 there to get t by itself. So that gives us the solution, which is actually an inequality. So that's going to be 7. So t is going to be less than or equal to 7. So since I have 7, I'm going to make my 0 a little bit more to the left. So 0, 1, 2, 3, 4, 5, 6, 7 is going to be here. So again, notice how, again, it's pointing to the left. So, and notice how it's equal to. So I'm going to use a bracket there at 7. And again, it's going to be going to the left to infinity, negative infinity. So that should be my shading, would be something like that. So for interval notation, it's going to be from negative infinity to 7. But the 7 is going to be using a bracket for a closed boundary. So to solve this inequality, the first thing we got to do is bring the negative through the parentheses. In other words, we actually got to multiply the negative 3 through the parentheses. So this is going to give me a negative 6x minus 6. Then the 15 drops down, less than 6 comes down. So notice how we still have some like terms on the left side. So this is going to give me negative 6x, and 15 and a negative 6 is going to be a positive 9, and then that's going to be less than 6. So again, if I lose 9 on both sides, notice this is going to require a little bit more work. So negative 6x is going to be less than a negative 3. So if I divide both sides by negative 6, notice how we divided both sides by negative 6. That's the same thing as multiplying both sides by negative. So in other words, this is where the inequality symbol has to switch. So this is going to be x is greater than 1/2. So 1/2 is going to be like 0.5. In other words, we're going to be between 0 and 1. So if I have 0 here, I'm going to put 1 here, and 1/2 is going to be right in between there. So there's going to be more 1/2. So you almost may want to make big tick marks, little tick marks for half marks. So 2.5, 3, 3.5. So we kind of see our scale going on there. So I have to be greater than 1/2. So notice how it's greater than 1/2. That means you're shading to the right. And since it's greater than, we use a parenthesis for that. And we have to be greater than, means we've got shade to the right there. So the interval notation here, we would actually have a left boundary this time, which is a parenthesis. The 1/2 would be here. And then we go to positive infinity, which would also be a parenthesis there. So that would be what we call our interval notation for that. So the next thing we want to talk about is what we call compound inequalities. A lot of times we'll be using the word and or the word or in this situation to create what we call inequality statements. The and means both conditions must be met, and usually is written as a between statement with the x being in the middle. The or means only one condition must be met. The word or is used and the answer remains as inequality. But again, like we were saying, the union symbol is used instead of the of for or if we're using interval notation. So we use the or if it's inequality notation. We use the u if we're using interval notation. So if I want to solve this, this is a compound inequality. This is actually an and statement. Both statements have to be true. The way I solve it is I just get the x in the middle by itself. So to make the coefficient of x a 2, the coefficient x, which is a 2, to a 1, we have to divide the middle by a 2. But we have to divide everything by 2 to keep it balanced in that sense. We're thinking in equation math. So this is going to turn into 3 is less than x, which is going to be less than or equal to, those are both less than or equal to, 4. So notice that the answer is between 3 and 4. So on my number line, if I have 0 here, 1, 2, 3, 4. Notice I may want to make my tick marks kind of far apart because we're between 3 and 4. So notice how I have to use a bracket for the left bound, which is my 3. I got to use a bracket for my right bound, which is a 4, and my shading is between there. So what that means is you got to be you have to be greater than 3, and you have to be greater than 4. So what this means is this is saying x is greater than or equal to 3, and x is also less than or equal to 4. But instead of writing like this, we prefer to write it as a between statement like that. Now, to write as interval notation, the left bound is a closed interval, so we have a bracket 3. The right bound is a 4, and we have a closed bracket, which is 4. So the numbers between 3 and 4 would make this statement true. So remember, the only numbers really between 3 and 4 are also those fractions and decimals, because again, we're talking about the set of real numbers, which means no gaps. So if I want to solve this inequality for x, I want to get the x by itself in the middle. So I'm going to go after the constant first. So I'm going to add a 2 here, but I have to add a 2 over here, and add a 2 over here to kind of start it out. So this gives me a 6 is less than or equal to a negative 3x, which is going to be less than or equal to, this should be a negative 6 over here. This is going to be less than or equal to 6. Now, if I divide by negative 3 here, I got to divide by negative 3 over here, and I have to divide by negative 3 over here. But since we're dividing both sides by a negative, what that means is these inequality symbols all have to reverse direction. So this becomes a 2 is greater than or equal to x, which is going to be greater than or equal to negative 2. Okay, so notice how, again, this really means less than, x has got to be less than 2, and it's got to be greater than negative 2. So it probably looks better if I write the smaller number on the left, the negative 2 is less than or equal to x, and the bigger number on the right, like that. So I may want to reverse that. But notice how I didn't change the direction of the inequality symbols. Notice how with the negative 2, it's eating the x. It's still eating the x. With the greater than 2, notice how it's still eating the 2 over here. So notice how it's easier to make the left bound right bound if it's in, if we're using less than symbols as opposed to greater than symbols. So notice how we like to use less than or equal to symbols in this situation. So if I have a 0 here, negative 1, negative 2 would be here. 1, 2 would be here. So again, negative 2 would be my left boundary, so I have a bracket. 2 is my right boundary, so I have a bracket. And then I shade in between there. So my inequality, now my interval notation is going to be bracket, negative 2, 2, bracket. So what that means, all the numbers between negative 2 and 2 in what we call interval notation. So if I use an OR problem, notice how OR, we have to also use the union symbol there for interval notation. So this one here, basically all we gotta do is solve each individual inequality and put them on the number line and just see what happens here. So I have to add a 1 to each side to start with. So I have a 2x is less than or equal to 8. Divide both sides by 2. So x is going to be less than or equal to 4. Or if we divide both sides, this is just by 3. This is going to be x is greater than or equal to 5. So or just means you just got to be either less than or equal to 4 or greater than or equal to 5. Notice that you can't be both those at the same time. You can't be less than 4 and greater than 5 at the same time. So that's why the or is important in this situation, is we have that going on. So I have this 4 and 5 going on here. So 1, 2, 3, 4 is right there, 5 is right there. So notice how we're less than or equal to 4. Notice how, again, 4 is going to be my right boundary, and I'm going to be going left here. And then greater than or equal to 5, the 5 is actually going to be my right boundary. Sorry, it's going to be my left boundary, and I'm going to be shading to the right. So notice how, again, the inequality symbol is pointing to the right. That kind of tells me to shade to the right. So those inequalities I would have then, the first one I would have negative infinity to 4 with a bracket in union with 5 to infinity, like so. So that would be what we call our interval notation. So doing one more of these, I have negative 2x is greater than equal to 8. Notice that if I divide both sides by negative 2, I have x is greater than, actually, since we divide both sides by negative 2, we have to also reverse the inequality symbol. So it's going to be the less than symbol, less than negative 4. So if I divide both these sides by 3, I'm going to get x is greater than or equal to 9. So from a number line perspective, I'm just going to rough out my number line here. Didn't have one. So I have my 0 here. 1, 2, 3. Negative 4 is over here. Notice that you got to be left of negative 4. That means you're going this way. So the negative 4 becomes my right side boundary. And since it's less than, we use a parenthesis there. So that's what my shading looks like there. And then I have this 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be here. And I got to be greater than or equal to 9. So notice how it's pointing out to the right. So I got that. But so the 9 actually becomes my left boundary. And I have to use a bracket since it's including the 9. So since this is an OR statement, we have these two things to write down. So we have negative infinity to negative 4 in union with 9 to infinity. That would be how I would describe that set using what we call interval notation. So lastly, let's see what else we have here. Have a few more things to talk about. So also in this lesson, we have what's called subsets. So this kind of a C shape or sideways U is the subset symbol. So this symbol stands for is the set of, is a subset of, is a subset of. A set is a subset of a second set only if all the elements are in the second set. Some other things to pick up on is every set is a subset of itself. So if we have a set and we're comparing it to itself, it's a subset of itself. It also points out that the empty set is a subset of every set. So again, empty set is a subset of A. So empty set, we either use this notation here or we use the braces with nothing inside the braces, also stands for empty set. So those are the main two symbols that you'll see here. So let's look at some questions here. So we have the set U is the big set. So we have the number 0 through 9 there. A is 1, 3, 5, 7, 9. That looks like odd numbers. B is 0, 2, 4, 6, 8. Looks like even numbers. C looks like it's a smaller set than that, 1, 2, 3. D is just a set of 1, and E is what's denoted as the empty set. So the first question is A a subset of U? In other words, does every element in A belong in U? So if we see 1, 3, 5, 7, 9 in U, then that's a true statement. 1, 3, 5, 7, 9. So A is going to be true because every element in A is in U. Is B a subset of U? Well, 0, 2, 4, 6, 8 are the values in B. Do those elements exist in U? 0, 2, 4, 6, 8. So yes, that's true. So this says, is A a subset of U? I'm sorry, is A a subset of B? Are all elements of A in B? Well, they're not. So C would be a false statement because the elements of A do not exist in the set B. D says, is C a subset of A? Well, C is 1, 2, 3. A is 1, 3, 5, 7, 9. Notice that not all the elements of C are in A, so that would also be false. So E says, is C a subset of U? Well, C's got 1, 2, 3. E's got 1, 2, 3 in it as well, so that would also be true. F says D is a subset of A. Well, is D a subset of A? Well, D has 1 in it and A has 1 in it, so that would be true. G, is E a subset of U? Remember, the empty set is a subset of any set, so it would be true. So the empty set is always a subset. And it says, is E a subset of B? Well, again, E is empty set, and an empty set is a subset of any set, so that's also true. Okay, so we have that kind of going on there. So we mentioned the word union, but we didn't mention the word intersection. So union kind of means that both sets are put together. So let's see here. So two common set of operations are union and intersection. The union of two sets is a set that includes all elements that appear in either of the two subsets. So union kind of puts both of them together. Also, as we said, union is associated with or. So you don't have to be in both sets at the same time to be true. You just got to be in one of those sets to be true. So the symbol for union, as we said, is the kind of the more of the U shape. So the colored portion in figure 722 represents A union B. So notice how A and B union means put it all together. Everything. So anything in A works, anything in B works, or whether they share works. So that's kind of what union means. The intersection of two sets is a set that includes all the elements that appear in both sets. So intersection means only where they overlap, if you will, what's in common in each set. So intersection a lot of time will be associated with the word and. And notice that the symbol for intersection will be the upside down U, or if you want to call that an N, you could. So notice that the code portion in 723 is an intersection. So notice how we have this Venn diagram again. So we have this Venn diagram where the green represents the whole set. A is a subset of that, and B is a subset of that. And where they overlap would be described as A intersection B. So let's see if we can put this together. So A union B kind of means everything in A as well as everything in B. So A union B would be the set of, so I have 1, 2, 3, 4, 5. I have 1, 3, 5, 7, 9. So if I put both sets together, that's 1, 2, 3, 4, 5, 7, and 9. So that would be A union B. So A union C would be combining set A with set C. So this would be A, this would be B. A union C means we have 1, 2, 3, 4, 5, and 2, 4, 6, 8, 10. So we'd have the set of 1, 2, 3, 4, 5, 6, 8, and 10 would be A union B. B union C means to put B and C together, combine them. So you just got to be in one set or the other. So that's going to be 1, B union C be 1, 2, 3, 5. I'm sorry, we got 4 as well. Let's see here. So 1, 2, 3, 4. So good. B union C. So 1, 2, 3, 2, 4. We have 5, 6, 7, 8, 9, and 10. So that should be B union C. Let's just put the elements together. D is A intersection B. Intersection means only what they have in common. So where they overlap. So they both do have a 1. They don't both have a 2. They both have a 3. They don't have a 4. They both have a 5. And they don't have any other elements in common. So only what's in common is intersection. So E A intersection C. So only what A and C have in common. So I see that they both have a 2 in common. They have a 4 in common. And that's all I see in common. So just that 2 and 4. F, I have B intersection C. So 1, 3, 5, 9, 2, 4, 6, 8, 10. Notice that they don't have anything in common. So either I can use like this here as an empty set, or I can just use this symbol here for empty set. So they don't have anything in common, so that's an empty set. So that's the definition between union and intersection. So the last thing we're going to get into looks like is complements. Another set operation is what we refer to as a complement. A complement of a set is a set that includes every element of the universal set that is not an element of the given set. So complement is kind of the opposite of what's present in the given set. So the symbol for complement is what we call the prime symbol. It looks kind of like an apostrophe. So if I have this little apostrophe looking guy, we use that. It's kind of stands for a prime. So if I have A apostrophe, that actually stands for A prime. And that represents the complement of A. So notice how A is the circle. The complement of A would be everything outside the circle. So if I want to find the complement of A, so we have U is our universal set, the whole set. A is going to be a subset, B is a subset, and C is a subset of U. So A complement means the elements are in U, but that are not in A. So the complement of A would be what we see in U, but we don't see in A. So I don't see a 0 there. So it's a set of 0. 1 is present. 2 is not present, so that's going to be part of the complement. 3 is present. 4 is not. So it's those even numbers, 0, 2, and 4. So if I want to do B prime is the elements that are not in B, but are in U. So since B is like 0, 2, 4, I'd be looking for the complement of that, which would actually be the odd numbers, 1, 3, and 5. C would stand for C prime. So C prime would be what's not in C, but's in U. So that's going to be 0, 1, 2, 3. So that means 4 and 5 would also be part of the complement. So D, what that stands for is A union B. So A union B stands for all the elements that are in U and B. So let's see if we can piece this together. A union B is like, we have the set of 0, 1, 2, let's see, 3, 4, and 5. So that would be A union B is the elements that are both in A and B. The complement would be what's in U that we haven't written down already. So if we wrote down 0, 1, 2, 3, 4, 5, well, U is 0, 1, 2, 3, 4, 5. So the complement would actually be an empty set because A union B would be everything. So E would be A intersection C prime. So first off, we have to find A intersection C. So what do A and C have in common? A and C would have a little A intersection C down here. A and C both have a 1 in common, and they have a 3 in common. So they have a 1 and a 3 in common. So that's A intersection C. So the complement, because we have this little prime symbol here, the complement means what's in U that we don't have here. So if we wrote down 1, 3, we won't write everything but 1 and 3. So it's going to be the set of 0, 2, 4, and 5. So that would be the complement of A intersection C. So that tells you a little bit about some set notation. All righty. So that concludes my lesson on inequalities and sets.